By the way, an intruder
What
wouldn't want
signs
to
are
connect to that. Like, how would they accept if we not know how to?
Okay,
Or I just outside.
here we go, guys. Yesterday, we were learning how to type things in on our calculator, and we were kind of in the middle of all that. So let's get our calculators back out. We're on page 42 of our notes, and we're going to do problem 4D. 4D, as in dog, on page 42. Okay, and we're doing nothing. Here it comes. Somebody said it's going to be late. We are going to make sure to do problem number D. We got to make sure our calculator is set in radians. So go to mode, highlight radians, and press enter. It may already be that way if you haven't used your calculator since yesterday. Everybody in radians? And then we're going to type cosine pi, and we're actually using the pi button. So second pi, that's under the clear there, divided by 9. Cosine pi over 9. Yep. You should have gotten 0.9397.
Is that a new calc?
No.
Right, is that a new calc?
0.9397. So, I want everybody to listen a minute, because he wasn't listening. He typed in exactly what he was supposed to type in, cosine pi over 9, but he got the wrong answer. And why did he? He was in degree mode. You're in degree mode.
Oh, I was in rating. I put it in the
If you're typing in a radian measure, you have to be in radian mode. You will not get the right answer if you're not. There'll be times you need to be, when do we need to be in degree mode? When the angle has a degree mark. So if it says 62 degrees, be in degree mode. Alright? Next, last one. Cotangent 2. We do not have a cotangent button. How do we type a cotangent into our calculator?
Sine?
Not sine.
1 over 10.
1 over. Look at your green sheet. What's cotangent?
2.
Reciprocal of tangent. So 1 divided by tangent 2. And the answer is negative 0.4577. All right, so let's really focus here. As we talked about this yesterday, if you need to type in a sine, cosine, or tangent, you're in luck because you got that button. You just press it. But if you need to type in a secant, cosecant, or cotangent, you have to remember what those things are. Cosecant, 1 divided by sine. Secant, 1 divided by cosine. And cotangent, 1 divided by tangent. Because you don't have those buttons. And there's no shortcut. The only way to do it is 1 divided by. Got it? Okie dokie, Smokies. Let's look at the next problem, which says find theta in degrees and radians, no calculator. So sine theta equals 1/2, and you need to find out what theta is. Now, I heard an idea. Change my attendance here. I heard an idea. Someone said divide by sine. Now let's talk about that. On your calculator, let's pick a number. Do 10 divided by sine. Try to do that on your calculator. Just 10 divided by sine. What happens? You get an error because what do you need to have? You can't just type sine, you have to attach it to something. So this is totally not allowed. Do not ever do that. It will never work, ever, ever, ever. You can, if this had been, sine 60 equals x over 5 or something like that, you can divide by sine 60 because it's hooked, but you can't divide by just that sine. All right, ever. So I want you to think about this for a second. What do we know about sine? What's the definition of sine? Sine is opposite over hypotenuse. Let me draw a picture. Here's my angle. And the sine is opposite, so I don't know what this angle is, but this is opposite over hypotenuse. Would you agree with that?
Yes.
Now, we looked at these numbers yesterday. When you see a 1 and a 2, this guy is going to be a root 3 because that's one of your special angles. Hint, hint, if you're not allowed to use a calculator, your angle's going to be special. So it's going to be a 30, 60, 90, or it's going to be a 45, 45, 90. Those are the only ones we have memorized. Other than that, we need a calculator. So taking a look at that triangle, is that my 30, 60, 90 or my 45, 45, 90?
No, that's 30.
That's 30, 60, right? And I want to know the angle that is across from the 1. What angle, you can look on your green sheet, what angle is across from the 1? 30. So what does theta equal? Theta equals 30 degrees. We are doing what we did yesterday backwards. Oh, what did you just say? Oh, we just really need to memorize it. Yeah. What does our green sheet say at the top? Memorize.
If you know that one is across from 30.
Then you're home free. All right, letter B. Secant theta equals root 2. So I'm going to draw my triangle. Here's theta. Now I need to label my sides. Now, your trig functions, sine, cosine, and tangent, are all fractions. So I'm going to think of this as root 2 over 1. That means one of my sides is root 2, and one of my sides is 1. And I just need to figure out where's where. Hypotenuse over adjacent is secant. How do I know secant? Because it's reciprocal of the cosine. And if we know SOHCAHTOA, then cosine is adjacent over hypotenuse, so secant will be hypotenuse over adjacent. So this is root 2 and this is 1. Which means this one is also
Then you just know it's 45.
1, and we know our angle is 45 degrees.
Good.
Right, we'll do one more together. We'll do C together, right? So this time the tangent is root 3. I'll make that root 3 over 1. The tangent is root 3 over 1.
The opposite is root 2.
So the opposite is root 3, and the adjacent is 1. Hypotenuse is 2, and the angle is 60. Now you do the last one by yourself. Cosine equals 1/2. What angle has a cosine of 1/2?
It's,
Isn't it the same picture?
yeah.
Adjacent over hypotenuse 1/2?
Yeah.
Same picture? So the angle is the same, so the angle is 60 degrees. Now tell me what question you have about that. You don't have a question? Okay. All right, now we're gonna get our calculators back out, and we're gonna work on problem 6. Now, you guys, why do we need a calculator? Because look at those angles. 57,
Degrees, not.
that is not special. What are our specials? 30, 60, and 45, right? Those are our special ones. If it's not 30 or 60 or 45, we're going to be using a calculator. If it is 30, 60, or 45, we won't use a calculator. All right, so let's see if we can figure this out. Solve for the variable. All right, so I've got this triangle, which they drew for me. I'm not creating it, they drew it. This is 57, this is 32, and I gotta figure out why. Now, this is the only angle they gave, well, they gave me that, of course, but they gave me, this is the only angle. Could I, if I really wanted to, figure this one out?
Yeah.
Yeah, but I don't need to, so I'm just gonna use this one. With regard to that angle, which side is this? Opposite, adjacent, or hypotenuse? This is opposite. And the other side I'm looking for is the hypotenuse. So we're doing sine. Why are we doing sine? Because sine is the function that uses opposite and hypotenuse. Now, some smart aleck is gonna say, well, so does cosecant. Yeah, but I don't have a cosecant button, right? So I'm not gonna do that. I'm gonna do sine, because that's the button I have. So sine 57. Remember, sine must be hooked to an angle. It doesn't mean anything unless it's hooked to an angle. So sine 57 equals 32 over what? We are solving for y. So I'm gonna multiply by y to get rid of the multiply by y to get rid of the fraction. And then divide by sine 57. Now, before you type this in on your calculator, boys and girls, let's look at that right there. What does that tell me?
Degrees.
I gotta be in degrees. So you gotta make sure that you are in degree mode. You can do everything right, and if you're not in the right mode, you're gonna get the wrong answer.
That makes sense.
So 32 divided by sine 57. It says round to the nearest hundredth, so that would be 38.16.
I'm just helping you.
Would I ever want an answer to this kind of problem to be negative? No. If you get a negative answer to this kind of problem,
You have negative for the
Sides.
sides.
Yeah. All right, do we feel okay about that? Okay, let's hear the next one. Okay, Braden, I need you to stop talking and just listen here for a second. We're gonna do another one, okay? So we're gonna draw our picture.
This is tan opposite.
Now, the first thing we need to do, we're gonna write an equation, we're gonna write a trigonometric equation. Sine, cosine, or tangent. So we gotta figure out which of those are we gonna use. Well, here's our angle this time. So which sides do we have? 18 is opposite, and x is adjacent. So the function we'll use is tangent. So tan 71, the angle is always hooked to the tangent or the sine or the cosine. Tan 71 equals opposite over adjacent. So we'll multiply to get rid of the fraction and then divide. So I will type into my calculator 18 divided by tan 71. Oops, 71. 6.20 if we're going to the nearest hundred. 6.20. Did you get that right? Okay, perfect. Oh. Now we have some word problems. Here we go. Draw a picture, write an equation, and solve it. All right, so let's draw a picture. We got a squirrel in the top of the tree. So here's the ground, here's my tree, and we're going to always assume that our trees, our poles, our people are all perpendicular. Okay, standing straight up. So here's my tree standing straight up. The tree is 52 feet tall. I got a squirrel up here, and he is looking down at a nut on the ground. So here's my squirrel, here's my nut. Squirrel looking down at nut. His angle of depression, this is important, his angle of depression is at 23 degrees. The angle of depression is this. If I'm looking straight ahead and then I look down, that is my angle of depression. So your angle of depression is actually right here. Okay? That's your angle of depression.
Is that always means?
That's always the angle of depression. It's measured from the horizontal. Now here's the good news. I learned in geometry that alternate interior angles are congruent. This angle and this angle are alternate interior. Do you remember that word, alternate interior? This angle is the angle of elevation. So pretend the nut is looking up at the squirrel. That is the angle of elevation. So the good news is the angle of depression and the angle of elevation are always equal. So it doesn't matter which one you have. You're always going to put it right there. I don't want to put it up here. It's outside the triangle. So I'm going to put it right here. So this is always going to be my angle of elevation or my angle of depression because they're equal. All right. Now what do I want to know? The question is, find the distance from the nut to the base of the tree. Okay, this is just what we had a minute ago. Pick a function. What function are you going to use? It's going to be sine, cosine, or tangent. What? TOA? Tangent? So the tangent of 23 will equal what? 52 over x. X tan 23 equals 52, and x equals 52 over tan 23. 52 divided by tan 23. Did you get 122.50?
You put negative 52.
122.50. Remember that your word problems will need a unit. And since the tree is 52 feet tall, it will be feet. How do you feel about that, okay? All right, next. What have I got now? I've got a seagull on the top of a lighthouse. So here's my seagull on the top of a lighthouse. And again, we always assume whatever they're standing on is perpendicular.
Are you always just gonna draw triangles?
Yeah.
Like, every single
That's the
one
whole
probably
lesson.
Do you know what trigonometry means? Triangle measurement.
Trig,
Yeah.
triangle.
Okay?
It's the one thing he's not doing.
Now, what's the seagull doing? He's 87 feet above sea level, and he spots a fish. So he's looking down at the fish.
Bro.
The seagull is 230 feet from the fish. So
Ooh,
where
we're
are we
looking
gonna
for
put the
hypotenuse.
230? It's the hypotenuse.
Doesn't matter.
You guys, here's the goal, here's the fish. If I had a ruler to measure it, this is what I measure, right? Now what am I looking for?
His little
The
depression.
angle of depression. Technically that's up here, but remember what I told you?
It goes back.
It's right here.
So it's really
There's
tricky.
theta, or x. I don't care what you call that. I put a theta there, you call it x, whatever you want. Okay? Sine, cosine, tangent.
Five.
Gotta be sine. Why does it have to be sine?
Because we only.
Because
Opposite
this
over
is
hypotenuse.
opposite, and that is hypotenuse. So sine theta, remember, the angle is hooked to the sine. So it's sine theta equals 87 over 230. Would you agree that I am looking for the angle that has a sine of 87 over 230? When you are looking for an angle, you use a new button. Yeah, use the inverse of the sine. So this is gonna be, theta is gonna be the angle whose sine is 87 2/30. You use the inverse sine. Use this button, use these buttons when you are finding an angle.
So not like when you're finding out.
Not when you're finding a length. You only use these buttons when you're finding an angle. So did you find second sine?
Just write it out there.
Right above sine, so second
22
sine,
points.
87 divided by 230. And our angle is 22.23 degrees. You only use these buttons when we're finding an angle. Are we clear on that? Okay. All right, see what's happening here. I have an airplane coming into an airport. All right, so here's my plane. Here's my port. Airplane's coming in for a landing. How far is an airplane from the airport? Now stop right there. That's X. Where does it go? Hypotenuse. Plane, port, right there, that's X. He is currently 5,000 feet above the ground. Is that good with everybody? And the angle of depression is 17 degrees. One more time. Technically, this is your angle of depression. But since it's not in the triangle, I'm gonna rewrite it down here as an angle of operation. All right, sine, cosine, or tangent? Sine. Why is it sine? Opposite hypotenuse. So sine 17 equals 5,000 over x. X sine 17 equals 5,000. X equals 5,000 over sine 17. got 17,101.52 feet. Okay, do you feel like you can draw your own picture for number D?
Yeah.
All right, let's do it. Mm-hmm.
We said that the angle of the present elevation is the same.
Yep, always. You always go right there. For D, did you put your 59 right here? And did you put your X right here?
Yeah.
Where did you put the 13? Bottom.
Yeah.
You guys, when you go outside, where do you see your shadow?
On the ground.
Your shadow's on the ground. The shadow's on the ground. Right? You don't see a shadow up here. It's not on the ground. Sine, cosine, or tangent?
That is, it would be opposite. Just tangent.
Tangent. Hypotenuse isn't involved. So if the hypotenuse isn't involved, it's gonna have to be tangent. So tangent 59 equals x over 13. So x equals 13 tan 59. $21.64. And that would be, is it feet again?
Height.
Yeah, feet. So awesome and fun. One more. What is the angle of elevation? So I'm just gonna put my X right there because I know that's where my angle of elevation goes. What is the angle of elevation of a man looking at the top of a building that is 48 feet tall if he is standing 100 feet from the building? Where do I put the 100? On the bottom. Now, when would I put 100 here? If he were 100 feet from the top of the building. Like maybe there's an eagle up there. How far is he from the eagle? But if I say how far am I from the building, I mean right here. How many steps? Sine, cosine, or tangent? So tan x equals 48 over 100. But when I'm looking for an angle, I gotta use a special button. I'll use second tangent. 48 over 100. So inverse tangent. 48 divided by 100. I got 25.64 degrees. Did you? Yes. 4-2, June Friday. 4-2. And here we go for 4-3. We have office hours on Friday, you have later hours tomorrow. We have office hours on Friday. So we are not figuring this out. And remember that the homework answers are always right up here. So you can check your own work.
I never knew that either. What? I didn't know that.
All right, here we go. We'll evaluate the 6 functions. Okay, so this is another one where we're going to be finding the sine, cosine, and tangent. Eli pointed out, is there always going to be a triangle? Yes. So you need to make it. Now, when you make your triangles, guys, make sure they are part of the butterfly bow tie. Those are the legal triangles. So if you're in quadrant 1, that's the triangle you're going to draw. We did a bunch of those yesterday. If you're in quadrant 2, 3, and 4, those are the triangles you draw. Notice they are sitting on the x-axis. You are not going to draw a triangle like that. Never. Butterfly bow tie when you draw a triangle. Okay, so we got my triangle drawn. Given in the problem, it says this point right down here is -3, -4. So does it make sense to you that this would be -3 and this would be -4? I'm going right and down, or left and down. And I know it's a little uncomfortable to put negatives there, but go ahead and do it. Go ahead and do it. That reminds me I'm in quadrant 3. Now, this is still your angle. Your angle is always the one that's at the origin, no matter which triangle you're in. These are your angles, okay, at the origin. So I know that my opposite side is -4, and my adjacent side is -3. I'm missing my hypotenuse, so what am I going to do? Pythagorean theorem.
Good, Roy.
So -3 squared plus -4 squared equals c squared. Remember, when you square, they become positive. So 9 plus 16 is c squared. So 25 is c squared. And c is 5. Important. The sides can be negative, depending on the quadrant you're in. But the hypotenuse is always positive. These can be negative, but that will be positive always. Okay? Now, are we ready to answer the questions? Yeah. This side is adjacent, this is opposite, and this is hypotenuse. So here we go. SOHCAHTOA. Sine is opposite over hypotenuse. -4/5. You gotta have the negative. Cosine is -3/5. And tangent, opposite over adjacent, would be +4/3. Why is the tangent positive? Because it's a double negative. Here, 15, here, is it an emergency? Is it an emergency? Now, how do I get those? I remember that they are the reciprocals. So -5/4, -5/3, and 3/4. In a fraction, it does not matter where you put the negative. Doesn't matter, you put it on the top, bottom, middle, doesn't matter. Put your negative somewhere when you write a fraction. One more of those. This time, my triangle is going to be drawn in quadrant 4. So remember, butterfly bow tie. Now I have to do some labeling. root 13? Anybody get anything else? Anybody else get root 13?
Yeah.
Okay. And now we're gonna fill in our things. Remember, this is always the angle right here, always at the origin. So what's the sine? Negative 2 over root 13. Cosine 3 over root 13. And tangent. Negative 2/3. And we just flip them. So negative root 13 over 2, root 13 over 3, and negative. Isn't that easy?
Pretty very.
Oh gosh. B looks a little bit trickier there. Let's see what's going on there. Point P is on the terminal side of theta in standard position. What in the world does that mean? The point is 2, negative 2. So standard position means I'm a butterfly bow tie and my angle is at the origin. So I've got some kind of angle that goes right to and down to. I can tell that from the point. The point tells me that. Okay? And I shouldn't have erased it all. I'm going to do the same thing. I'm going to find my sine, cosine, tangent. I'm going to mix these up. Cotangent, cosecant, secant. Mix these up now. See if you can get them matched up right. Alright, so what's the first thing we need to do? Pythagorean theorem. So go ahead and do that and tell me what you get. I think this is the first time this has happened to us. Did you get the square root of 8? And the square root of 8 can be reduced to root 2. And so we gotta do that. You have to reduce your radicals. I'm not making you rationalize, I'm going to leave things in the denominator, but you've got to simplify your radicals, okay? All right, we're ready to go. So sine is opposite over hypotenuse. Now guys, that reduces. Look at it, can I cancel a 2? So negative 1 over root 2. That is my sine. What about my cosine? 2 over 2 root 2. Same thing, we'll cancel 1 over root 2. Tangent, negative 2 over 2, which is just negative. Now make sure you got a little different order there than I have, so make sure you're getting the right things there. Cotangent would be negative 1. Reciprocal that, you still get negative 1. How about the cosecant? That's the reciprocal of the sine. So negative root 2. And then secant would be root 2. So please make sure you're getting those in the right spots.
What is it like the terminal side?
That's where the angle ends. So remember, our angles always start here. This one goes all the way around and ends here.
Oh, so it just wants to know about that.
Yeah,
Just
so
clarify.
just touch which point that you're in. All right, why don't don't you try B? B is exactly the same idea, but of course the angle and the numbers are all different. Try B.
Square root of 17.
So which quadrant are we in for letter B?
We're 2.
We're in 2, so triangle is butterfly bow tie, it's gotta look like that. This is -1 and this is 4, just like you're plotting a point. Start at the origin, left 1, up 4. Your hypotenuse is root 17, which does not reduce. So your sine is 4 over root 17. Your cosine is -1 over root 17. And your tangent is -4. How are we doing, okay? Did I have a question about that one? Feeling pretty good? Great. All right, new vocabulary word, number 2. Co-terminal angles. Let me draw an angle up here for a second. I'll just do 100 degrees. So would everybody agree that 100 degrees in standard position? Now, you guys, standard position means you start on the x-axis. That is different than navigation. Navigation is the exception to the rule. Navigation starts at due north. This is not navigation. This is a 100-degree angle.
We had like -100 and just
Yep. -100 would be the same thing, but it would go down, opposite direction. So there's a picture of the angle in question. Now, there are lots of other angles that would be drawn in the same place. Can you think of another angle that starts here and stops here? What?
260.
-260. -260. Now, how did he get negative Jackson? How did Jackson get
Oh, he just
negative?
subtracted 300 from 360.
Exactly. He knew the whole
Jackson.
revolution was 360. So if this is 100 of it, wouldn't this be 260 of it? But since he's going this way, like Eli pointed out, it's -260. This is called a negative coterminal angle. What does coterminal mean? It ends in the same spot. So if I go the other way around, I can end in the same spot, negative coterminal angle. Okay, think of another one. Another angle. Open your mind. Think of another angle that starts here and stops there. How about 460? What does 460 degrees look like? 460 would go all the way around and then 100 more. So would it stop in the same place? Yep, so 460 would be a positive coterminal angle. How did I get 460? I added 360. So the negatives are your angle minus 360, and the positives, these are the negatives, and the positives are your angle plus 360. To find coterminal angles, we add or subtract revolutions. And a revolution in degrees is 360. A minute would be 1 in radians. Now, is that it? Are those the only two possible answers to the question? No. What if I added 720? 820 would end up in the same spot because 720 is simply 2 spins. So you can find infinitely many coterminal angles. Just keep adding and subtracting revolutions. That is going to be useful to us in the not too distant future, so remember that. Remember that. All right. Oh my. Let's skip B for a second and do C, because it's another degree one. So give me a positive and a negative coterminal angle for negative 150. So my angle is negative 150. What would be a positive coterminal angle for that? Add 360. What do I get if I add 360? 510.
210.
210.
Oh, yes, sorry.
So 210 degrees would be a positive angle. What would be a negative one? Negative 510 would be a negative 1. How do we find positives? Add 360. How do we find negatives? Subtract 360. Okay. Now, what about B? The angle is 2 pi over 7. Any thoughts on that? Now, we're not going to change it in degrees. We're going to do it in radians. That would be what you were doing there, but we're not going to get rid of it in radians. Last problem of the day. Let's make it good. Okay, how did we find it? Oh, what did you add? No, but you're thinking along the right lines. When we did it in degrees, we added 360. Why? What's special about 360? It's a revolution. Okay, wait a second. What's a revolution in radians then? What's pi?
2 pi.
2 pi. Pi is 180. So wouldn't 360 be 2 pi? So you are going to take 2 pi over 7 and add 2 pi. You add a revolution, and a revolution is 2 pi radians. So we'll get a common denominator. So that's 2 pi over 7 plus 14 pi over 7. So 16 pi over 7 is your positive coterminal angle. How will we find our negative one? Subtract 2 pi. So I just figured that out. That's 14/7. So what's 2 minus 14/7? Negative 12/7. Big idea. To find coterminal angles, you add and subtract a revolution. If you are in degrees, that means you're adding and subtracting 360. If you're in radians, you are adding and subtracting 2 pi. All right, I think I have done enough damage for one day. So I would pause there. You have homework due
Where's that here for a while?
tomorrow, and you have homework due on Friday.